The syllabus talks about the difference between true stress and engineering stress. True stress. Load divided by the actual area at that time. The standard stress is the same load that's breaking a specimen apart, but that is divided by the original area. Let's look at this for 1 second. If I've got a specimen that might be 100 millimetres long, might be 10 millimetres squared. The volume inside that is 1000 millimetres cubed. Not really rocket science so far, correct? So, if I stretch that out by 10%, that is now 110 millimetres, the cross-sectional area cannot be 10 anymore, it's decreased. What's 1000 divided by 110? I think that's 91 millimetres squared. Could somebody with a calculator confirm that for me, please? Am I right?
Yeah.
Yep. Okay. So by stretching it out 10% strain, so that's 10% strain. If it hasn't necked, yep.
It's actually meant to be 9 millimetres squared,
Oh,
not 90.
thank you. 9.09. Thank you. Numbers were right, the decimal point was in the wrong spot. Good pickup. Then the surface area, or the cross-sectional area is smaller. Gotta be. Because it still weighs the same. Still got the same volume. Make sense? Then it just keeps on behaving like that until we get localised necking. Once you get localised necking in the specimen, every bit of deformation is happening there. That area now might go down to 5 millimetres squared, it might go down to 3 millimetres squared, it might go down to something ridiculous. What actually happens now? True stress in the syllabus. Engineering stress might look like this. It's a steel. There's the ultimate tensile stress when necking occurs at this point. Necking starts. So the ultimate tensile stress is when necking begins. The real stress, it's obviously a little bit higher. This is what they call true stress. Because the area is getting smaller, the stress has got to be higher. Yeah? And then if you think about what tensile stress is, it's a measure of hardness. The more you deform something, the harder it gets. It cannot get softer. Here it shows that it's dropping because the area is dramatically and rapidly decreasing. And that's force divided by original area. But what's happening, as I said, you've got a rapid local change. So instead of the load divided by 9, it might be the load divided by 5, which is double. So what happens here at true stress does that until it fails. Divide by 5, divide by 3 means 3 times as much. If it necks down to a point where it's 2 millimetres squared, 10 versus 2, 5 times less area, 5 times as much stress. So, that is what true stress curves look like.